Want to nail engineering manager interviews at MAANG and other top-tier companies? You can with USA's #1 tech interview prep platform. We have 300 plus SMEs and instructors from top-tier tech companies to help you land your dream job. We've helped thousands of engineers make their way into MAANG. You could be next. To learn more, register for our free webinar.
Hey, how are
Hi.
you today?
Doing good. How are you?
Okay. Yeah, pretty good. Okay. Yeah, I can see you and hear you pretty well. Okay, good.
Sounds
All right. So, yeah, um, we are going to have a mock interview on coding today. Okay. Yeah. Right. So, have you done like any mock interview before?
No, so I requested for the system design interview
Oh,
for today.
okay, that's fine. We can do system design as well.
Okay.
It's just the review form is, I think is the coding one, but yeah.
Oh, okay.
So, but that's fine. So we want to do system design, okay? Right? Yeah. All right. And so before that, can you briefly introduce yourself?
Sure, definitely. So usually, just before we start, so usually in the mock interviews, do we just like we can define the topic, or can we is it just like a open topic for a
Yeah,
mock
I'm going to
interview,
give you a
or
question. Yeah. So, good question. So usually I'm going to know a little bit about you and see whether I can because I have a lot of questions. So I just want to see whether there's a good one based on your background. So that's what I'm thinking. So,
okay?
but of course, you can also want to say, okay, I want to do this kind of topic, or I have a preference on this. That's totally fine. Actually, it's good. So I usually will ask you like, do you have any preference about a topic or whatever, right? So yeah, we can do that as well.
Okay. Yeah, because I have some slides for Messenger, so it could be a WhatsApp kind of messenger or a Facebook Messenger, if that is okay.
Yeah,
Or
yeah. Look, we can do something like that. Yes.
okay, sounds good. So let me start with introducing myself, and for the feedback, so would it be at the end of the interview or after the?
Yeah, after the interview. Yes.
Okay, sounds good. I'm working with Visa as a lead software engineer. So
Okay.
my role here is mostly managing a forex business solution. So I work for a B2B Connect team, which is building a platform for transfers of money between the corporates and the bigger banks on an international basis.
Okay.
Excuse me. So I deal with the forex platform of the forex module of the platform. So my role here involves mostly on the backend side. So I work on technologies like Java, J2E,
Yeah, I see.
using Spring Boot, and databases we are using MySQL on the backend side.
Yeah.
Also, we have Tomcat. Generally use Tomcat servers. Work with CI/CD and Jenkins uh, pipeline. So that's kind of a background which I have. So my role here involves lot of planning on the product. Uh, what are the upcoming features which we want to introduce, how to plan them. So I lead a team of about 7 people here. So all of them work on the backend side of it. So we use most of the RESTful APIs for interaction within the entire platform. So the Forex part, to give you a context of it, the Forex part basically deals with getting the foreign rate exchange rates from different banks and then providing it to the payment platform.
I see. Okay, good. Okay,
So,
good. Yeah, it's a very like a specialized area. Okay, domain. Yeah, how to
right.
this bank transfer or exchange, right? Okay,
That's
good. So thank you. So now is about today's topic. You mentioned just now like you want to do some like something like a WhatsApp or Messenger, that kind
yeah,
of thing. Okay.
correct. Yeah.
So yeah, do we want to do it like from scratch, or you mentioned you also have some slides? That one.
Yeah, I do have some slides, but feel free to like ask any questions in one specific area, so that would help me to understand more areas which I need to dive in.
Okay.
So let me actually do a quick share of my screen.
Okay. Okay.
So here are some of my slides. So if you want me to go over the slides, I can do that. Or if you want me to go over a specific area of kind of a messenger design, I can do that too.
Yeah. So okay, structure scalable system design. Okay, QA. Question and answer, is that okay? Facebook Messenger. Okay, good.
Yeah, I think yeah, this one is
Let's go through them slowly, and then I think I will ask some questions. Okay. Yeah, the function
okay.
requirement.
Sounds good. Sounds good. Okay.
Capture of
Okay,
online.
so mainly while defining a messenger service, our
Mhm.
main functional goals should be one-to-one conversations between the users. So the application should be supporting different platforms like a mobile app, a desktop, or any other Android devices, iOS devices. So all of those devices should allow you to have one-to-one conversations in a real time.
Uh-huh.
This particular application should basically allow to give you information about whether the user is online or offline, based on their availability of using that app.
Uh-huh.
um, and depending on if you want to store the chat history on like for future analytics, we could do that. If not, we could basically just deliver the messages and not save it on the server.
Okay.
um,
So this one also want to manage the users. Okay, the users, and also transfer the message. Okay, right, between the users. I see.
right,
Authentication, and also want to support group messaging. So you can send a message to a group of users. They
right.
can, okay, all of them can.
Multiple users at a time,
Okay.
yes.
Okay. All right. So and multimedia. Okay. Interesting. That one. All right. All right. Okay.
Right,
And on want to support both the cases when the user is offline and online.
right,
Both cases. Yeah.
yes.
Um, event-based messaging. Okay. A group chat.
I think
Okay.
group chats and group messaging are
Yeah,
useful.
there's a lot of functional requirements. I don't know whether you have time to cover them all, but
Okay, I
that's
can
fine.
focus on some of them, like
Yeah.
whichever would be
o-
most important ones.
Okay. Okay. And non-functional one, users have real-time chat experience. You're able to see chat histories, high consistency and availability, and no lags. So means like it should be almost real time. Okay.
Almost.
Good. Yeah. All right. I got that. I actually have a similar question I ask. It's just like but usually has less functional requirements, because I don't think like it can cover like all these in 15
Sure.
minutes. So but that's good if you can cover them. Yeah,
Okay.
it's a very similar question. So the main thing is you want to, usually I call this like an instant messaging system. So you
Okay.
can send a user send a message to one like this one message, or send it to groups, and the user can offline online. And
Okay.
also my question is also want to support one more case. And this one is if a user, they can use multiple devices to access the message, then how to support that? Yeah, that's just one more thing. Yeah, here you didn't have that, but sometimes, right? So because the user can use the iPhone or the iPad to get access to the message. So then how?
Login into the same
Yeah, yes. Okay, good.
same.
Go ahead.
Okay. So based on some of my research, I found these numbers that Facebook kind of have 500 million users who are using the chat application.
Okay.
So, and they have probably about 20 billion messages sent per day on the platform.
Okay. Okay.
So based on those numbers, I might be a little off, but yeah, based on like assuming that these are the numbers, so uh, if we have 20 million messages per day, and assuming that on an average each message takes about 100 bytes, so this does not include the multimedia messaging, so we would have to basically store information about 2 terabytes per day. So if we have to like basically think about storing this information in like span of 3 years or 5 years, it would be in petabytes.
Okay.
So that's the storage storage
You
constraint.
also want to support medians audience, right?
Yes. So our multimedia would be separate from the messages. So for that, we could probably use some kind of cloud-based solution to save that information.
Okay.
Have that information saved
Yeah,
on.
yeah. I
So,
may go to that part later, but let's. Okay, good. All right.
right. So and so that's the storage constraint. So let me give you a high-level block diagram of how would each component
Can you see the previous
be
slide?
divided.
The previous slide.
Sorry.
The previous slide.
Oh, this one just mentions what are the services which this
Okay, the
app
message
would
group
basically work
storage.
for.
Okay, I see. User activities. I see. User activities and
Yeah,
message.
so
Okay.
all of these services are available in this diagram. So that's the reason I kind of skipped.
All right. Okay. Load balancer and then a WebSocket. That's fine. Okay. And load balancer. Okay.
So let me give you like an overview of the picture which I have in my mind. So basically, each device will be connected to one of the servers, one of the sockets,
Yes.
to be able to interact with the rest of the system. So the system which I have in my mind would be in form of microservices. So each service is responsible for its own responsibility, and we will try to keep WebSockets as light as possible. So which would basically just act as interface between the main application business logic versus connecting to the devices. So we will I want to keep it as light as possible so that we don't have we don't put any business logic there. So in this diagram mainly I would be dealing with the message service, which would be responsible for connecting, having different messages from different users and like saving them for future analytics. Asset service would be one of the services which would deal with the multimedia kind of messages. So we can.
I see. I got okay. Go ahead. I have some questions here, but I will let you finish first. Yeah.
Sure. And also group message handler and group service would mainly deal with the group messaging. Group messaging when a user sends message to a same set of people in a group. And also we have user activity or user service, which would basically have information about the users. So based on the functional requirements, I was not able to complete end-to-end functional requirements diagrams for each functional requirement, but I can walk you through what each functional requirement, how would it be implemented. So for one-to-one messaging, what suppose user 1 wants to send messages to user 2, the message sent is being P1. So for one-to-one message, how it will flow through the diagram is it will be connecting to the WebSocket handler. The user when logs in, it will be connected to the server. And when the user wants to send the message, it will send the message through this handler. So as soon as the user sends this message, it will get this WebSocket handler will pass the information to the WebSocket manager, which would basically have information about how other devices are connecting two different servers. So basically, it will have a mapping of user versus the server. So if
So I
I
have, okay, good. Just excuse me. So one question here: the handler, what is the handler? Is it like a service, or is it more like a lightweight?
it's just a server where we will basically connect the user while it's the user is active. It's just a server to connect to the users,
Okay,
active, to maintain active connection.
I see that. Okay, that's the socket, right? Okay.
Yes.
So that's socket manager. So the manager, what is the web socket manager? What is it doing, and what kind of like data structure or algorithm is using?
Right. So WebSocket Manager basically will have information about each user connected to each server. So it will
Okay.
have a one-to-one mapping of, like, user 1 is connected to WebSocket handler 1, user 2 is connected to handler 2, user 3 is connected to 3, or user 4 is connected to 2. So that kind of one-to-one mapping will be provided by the WebSocket Manager. So it would be a kind of a service which would give us information about which device is connected to which server for easy flow of the messages.
Okay. One question. Okay. Is user user 1 and user B connected somehow or no?
So user 1 and user 2 are not connected to themselves directly. They are all only connected to the servers.
Okay. Okay. I see. Okay. So user 1 send a message and send it through the WebSocket and send it to the WebSocket manager,
WebSocket
and then
Manager.
again the manager will send the message to user 2 through
That's
the WebSocket and handler.
right.
Okay, I got that. So and the Redix. Okay, yeah, this is the storage.
So Redis would be the cache. So the most active users, we could define it based on who are the most active users, based on the locations. So we could basically identify users which would be added into the cache and refreshed very frequently on the Redis. So if a user is connected to user 2 and is sending messages, so we could cache the information of user 2 connected to which server, so that information can be saved, that information can be used quickly, and we don't have to retrieve it. But
okay. So the Redix maintaining the connection information.
correct.
Connection
Yeah.
data. Okay, I see.
Yeah. WebSocket Manager Redis connected to this cache will maintain that connection information. It will also have a backend database information, but
Yeah.
we can reach out to cache to get that information.
Okay, I see. Right. Okay, I got that. Yeah.
So I think the second slide is also kind of similar thing. It will save the information. Database is stored the user to box mapping, and it will connect to the WebSocket Manager.
Okay.
So going on to the second functional requirement, which says keeping track of offline and online status of the users and send and read receipt. So I would like to cover it over here itself. So right now we are sending a message from user 1 to user 2. The message T1 is being sent. So in the same flow, how I think I would like to configure it is user 1, as soon as it sends the message to WebSocket handler, it will basically get an acknowledgement that the server received your request to send it to user 2. Right?
Okay.
So the first acknowledgement, which is basically sent, would be received by user 1.
Okay.
Now, WebSocket handler connects to WebSocket Manager, gets the information about user 2, like which box is it connected to, and it redirects the message to socket handler 2 and sends it to user 2. So if user 2 is online, the socket handler 2 will send the message to user 2. If it is not online, it will sorry.
Okay.
If it is not online, so basically sorry, let me first complete the flow, which is a positive scenario, like a happy path. So if it is online, it will get the message and instantly it will send a message back to WebSocket handler 2 that it has received the message. So this received message acknowledgement will be rolled back to user one by using the same path using the WebSocket manager. And since the message is T1, it will be identified by a message ID, which will be maintained in the WebSocket manager database to see how each function is, how each is the message received, sent, or read. So basically, we will maintain states per message, that each is this message received, is this message sent. So once this message is received by user 2, we will update the database to say that a T1 message with this particular message ID has been received by user 2. So it will also maintain information about the users, who is the sender and who is the receiver.
I see. So, but you still keep the message. You don't delete it, right?
Yeah, we don't delete it yet.
Okay, I see. All right. So I think that the flow is quite clear. Yeah, how message is from a sender to a receiver. I think that part is quite clear. Okay. So the flow. All right.
So similarly, we will update as soon as the user 2 reads the message, it will be updated by read message to the user 1, and once it is delivered, we can choose in our application. If it is Facebook Messenger, we could save that information. WebSocket manager can reach out to the messaging application and save that information into Cassandra, like if we want to use it for future analytics. If we want to save that message in our own database, so for future analytics. So that's how we could basically save that information.
Why Cassandra?
Because Cassandra is like non-relational, and we don't have a lot of relation in this. We are just saving that information for for analytics in future. So it's basically kind of a database which is ever increasing. So Cassandra kind of supports that.
Okay. So is there like any alternative?
HBase can also be used.
Okay. So, and
those are the two popular ones.
Can you tell me that the data schema? So what exactly is stored in the database?
Okay, so for this messaging service or the entire application?
The message, just the message. Yeah.
So just the message, it would just contain the user information as well as the message. It will.
The user information, is it the sender, the receiver, or and the message text?
Both, and the text.
Oh. Okay. Okay, I see. Sender, receiver, and text. Okay. All right. So how about what if the receiver is offline?
Okay, so if the receiver is offline, basically what will happen is the receiver is offline means the WebSocket handler is like if we have the information when was the receiver active, so we could identify whether the user is active, last when was the user seen, based on every time the user logs in. There could be so basically let me go back to this diagram here. So taking a step back, so every time a user logs in, we would basically from the application, it could enter like we could have a pulse which would identify whether the user is active or online right now and make an entry into the user activity table. So this table will have information about user ID and the last seen timestamp.
Okay.
And we could have a threshold that we would update any users which are active within last 15 or 20 seconds. We will just update them as active right now, or was seen 1 minute ago, was seen 2 minutes ago, or something like that, based on this timestamp. So now if a user is offline, so suppose U1 was sending a message to U2 and U2 is offline, so what will happen is the WebSocket manager will send the message to WebSocket handler 2, and if it sees that user 2 is offline, it will respond back that this user is offline. This message would be sent to the queue message service, and message service will add it into the queue saying that this message is offline for user 2 and it's not delivered.
Okay, I see.
So every time, so now when the user 2 comes online, it connects to WebSocket handler. It will reach out to WebSocket manager, which will check if there are any messages for user 2. It will send it out all the messages to user 2.
So, so let's say that again. So user 2 become online, right? So maybe like after work. So how can the user get the message? They go, sometimes they go to multiple messages, right? Not just one. Yeah.
Sorry, come
So suppose
back
user 2 just get online again, okay? And then maybe he has multiple incoming messages. So how can he get off them, basically?
So in the queue, we will have all the messages. Suppose say user 1 sent some messages to user 2, user 4 also sent some messages to user 2. All are added.
Okay.
All are added into the Kafka queue, and as soon as user 2 sends opens the app or comes online, it will send a message. It will send a pulse to the user activity, which would log the timeline that this user is active. Also, the WebSocket handler will send a message to WebSocket manager to see if there are any messages. So WebSocket manager will reach out to message service, and message service will check in the Kafka queue that for user 2, are there any undelivered messages?
Okay, I see.
So all the undelivered messages ordered by the timestamp will be delivered to the user 2.
Okay, I see. Right, store in the Kafka queue and get them. All right, I see. Okay, I understand that part. Now what is the access service?
Which one? Asset service. Okay.
The bottom one. Yeah, the access.
Okay.
Yeah.
So basically now for the functional requirements where user 1 wants to send an image or a video to user 2, so that's when asset service would come into picture, because it's a multimedia kind of upload into the system. It's a multimedia communication. So what will happen is user 1 will upload a multimedia image or a document, and once it is connected to WebSocket handler, when it is trying to upload, WebSocket handler will reach out to WebSocket manager and see it's a multimedia. So WebSocket handler will connect to the asset service, and asset service will upload the content in the S3. S3 is like a cloud platform where you could save your information. So here I'm using S3, where all the multimedia information can be saved into that server. So before any image can be uploaded into the server, on the application itself, that image or video will undergo some compression. It could use multiple different types of compression techniques for that multimedia asset, and once that is done, it will save the information onto the server in a hashed format. So basically it will upload the image or the video onto S3 content and assign an ID to it now, and also assign a hash create a hash of that image or a video, and return it back to user 1, to the WebSocket handler 1, and then pass it as a regular message instead of the multimedia. So that hash and ID would be sent to the WebSocket manager to be sent to user 2. So now when user 2 looks at that message, it will send the hashed key, because it's a multimedia asset. It will send the hashed key or hashed value to the socket manager to get basically when it is being sent, it will look into the S3 network asset service to get that information downloaded on their machine, on their application.
Okay, I see. All right. Oh, okay. And okay, the one more question about this functional requirements thing is the group service. So what is that doing?
Okay,
The group,
so the group message handler, basically group service will deal with messages which are sent to the group. So if user 1 and user 2, user 3 are all in the same group, and user 1 sends a message to group 1, which includes 1, 2, and 3 users. So what it will do is same path it will follow. Go to the WebSocket Manager. WebSocket Manager looks for a group, sees that this message is being sent to a group. So because it is a part of a group ID, it will go to the group service handler and ask the group service handler to give all the users which are part of this group.
Okay.
So handler will pass the request to service, which will basically get all the mapping of group IDs for that particular group
So
name.
basically,
So
the
now
service is to know like what are the users in that group.
in that group, yes.
Okay, I see. And then once you get that set of users, so then what will you do? You just send the message to them one by one?
Yes, so once I get the message, I would send the message to all the users except the sender one by one using the WebSocket Manager.
Okay.
Because WebSocket Manager will, once I get the users and the user's ID, the WebSocket Manager will help me to identify which box is the user connected to, which WebSocket is the user connected to, and help me pass the message like a one-to-one message.
Okay. All right. Okay, so now I think we cover this high level flow, all these function requirement pretty good, pretty well. So let's say now let's look at these non-functional requirements. So can you talk a little bit about that?
Sure. So basically, each of the services I see here can be scaled horizontally. So if we have, so WebSockets are kept as light as possible, but they are faced by a load balancer, because like if a user is moving around, so every time the user is connecting to the application, the load balancer will allow to move the connections to different sockets at different times. That would be easier. Also, if there is a load balancer will help to divide the number of connections on different socket handlers based on location, based on areas, and based on the load of each server.
Okay.
So go ahead.
So the question is like you're going to use a lot of servers here, right? And the load balancer is to try to basically distribute
Right.
the incoming requests or the connection to this server.
Correct.
Okay,
Mhm.
I see. And
And
how long are you going to maintain that socket connection?
so that socket connection can be maintained for probably about, if the user is active. If it is inactive, we can maintain that connection for a threshold of say 24 hours or 2 days or 3 days, if that works. Like it depends on how long do we want to keep a connection. So if our bandwidth is very less, we could reduce the number of hours. If we have less number of infrastructure available, we could reduce the number of connections on each server to a lesser number.
Okay.
But
Okay.
since these applications are connected by phone, most of the applications are online most of the time. There are a lot of applications which are, lot of users which are connected through web. So those connections can easily be switched to be used by the other users.
Okay. All right. So I see. So and then if you have many users like active users, right? So what will you do?
So if
Like
ideally WebSockets are able to handle about 65,000 connections in ideal world. Like, but right these days people have kind of figured out different ways to increase the number of connections to one socket handler. So that is the one basic reason why we don't want to
But you
basically.
the port number?
Sorry?
By using the port number?
Yeah.
Okay. All
So,
right.
so that is the reason why we want to keep the WebSocket handler pretty lightweight and not do any business logic there, so that they are able to keep the connections and we don't have to burden the server with that, with any
Okay.
business logic.
All right. And okay, so if you say like Facebook have these how many, like 500 million users, it's more like half users, right? And
Right.
what do you think is there any like major scalability challenge here?
The scalability challenge is maintaining the active connections. And so active connections is one, but since we can scale the WebSockets by keeping them lightweight, that could be easier. And one of the things which would be a challenge is because a lot of people are using mobile devices, right? So
Yeah.
they are on the go and they will have to connect to, like, basically we have to define the WebSocket handler connection in such a way that even if they are moving, they are able to connect to the same socket handler and not see lot of lags and issues there, like making the connection to different servers at all the time.
Yes. Okay. Yeah. I think using this WebSocket to maintain a connection is important to make sure you can transfer the data like
Right.
fast. Yeah. Now, okay. Is there going to be any like challenge to the Kafka or to the Redux or to these microservices?
Yeah, in the microservices, Kafka is one would can be a kind of a bottleneck where if we are saving information synchronously, it might cause some issues because there are like 500 million users who are using this application.
Yes.
So Kafka might become a bottleneck in that case.
Uh-huh.
So there could be other ways where we could use a database as queuing up the information, or just use um, cache to not save information which is in transient format. So
Okay.
basically we don't save that information in the queues. We in Kafka, basically Kafka would need a consumer, and it will have to modify the information and save it into the Kafka queue and move that information around the different services. So Kafka is useful in terms of if we are doing any asynchronous processing on the background, something like we want to save the messages into the database for future analytics. So we could use Kafka for that, so that it does not basically slow down the responses to different messages, message transfers, data transfers, but also at the same time we keep track of whatever message is being transferred along the system. So Kafka can take dump and asynchronously put that information into the database for analytics.
Okay. I see. All right. So now, I mean, like think of the real cases. Okay. So because we design this system, if we want to use it for Facebook, right? So what could be the cases which something goes wrong, okay, or something is just like unusual? Is there anything like,
I would think that like using lot of caches might be difficult because there are so many users. So if we are using a lot of cache, we would have to use it very efficiently in such a manner that we don't overkill using a cache, because every time if we want to go back and check in the cache and if it is not there, go back to the database. So if there are so many users, we would have to use it so efficiently that we get what cache is supposed to do, get that information right away. So if we are using the WebSocket manager with the cache, right, for example, and we are getting information of each user, where this user is, like which box is it connected to, and that information, if it is getting refreshed very soon and with the number of users, it would not make sense to cache it into the system, because every time the manager would look for the box connection and it's not finding it, it's adding to extra lag for the responses.
Okay. So I have one question here about the user activity service. Okay. So is it like you mentioned you're going to see where maybe like when the user is online or offline, that kind of information. So anything else you want to use that service for?
That service can also be used to save information about the user. So user once log in will have all that in, so user activity service will have the information about the user.
All right.
But that would be basically very less read capability, because when the user is logging in, putting in the details, it is very unlikely that we would go back and read the users. So if there are 500 million users, there is a very less chance that per second or per minute we have lot of reads from that system to update those values. And also, like writing into the database about what time is the user active is a very heavy database write system. And over here we are kind of updating each record per user. So that would basically cause that might cause some deadlocks over there on the system, because it's on the network.
Okay. So now let's talk about one more like functional requirements. Okay. You mentioned like you're going to, is that like the message can be searched? Is that, I mean, can we go back to the functional requirement and see? Let's go back to it and see whether one more. Okay. Yeah, support. Okay. Okay, persistent storage of the chat history. Okay. Didn't need that. All right. So okay. Yeah, how about the push notification one?
So yeah, so if it's the same thing which we talked about if the user 2 is offline. So what we could do is a lot of applications are available, but the user is not actively using them. So it's basically we can categorize the users into live or active users. And if the application is logged in into a phone or a device, something where we can push the messages, what we can do is if the user is not live on the application, we could just send it to the WebSocket handler, and it will, based on the settings of the device, it will push the messages to the system from the sender.
Okay. All right. I see. So one more thing is the user can see the history, right? The history or the history messages. So how do you support that?
So users can save that information into the, so for Facebook kind of messenger, we save that information in the database, right? For each user, it will be saved into the database. But if it is something like some other chat application which does not support that, so it would be saved in the user's memory of the device.
Okay, that's cell phone, you mean? Like,
yeah.
I see. All right, so I got that. All right, so we have a couple more minutes to the design. Do you want to add anything like major components or major optimizations into your design?
So one of the optimizations I see definitely would be there, how to keep track of whether the users are active or inactive, because it is very heavy read or like not read, sorry, very heavy update system. If I have to design it in a way where I don't have to keep updating the database,
Yeah.
it would be easier to keep a track of it, and it will not cause a lot of bottlenecks.
Okay. All right. Okay, so I think we can stop here, okay, and just discuss about it. All right. So first of all, I would say like the way you present a design, I think that's good. That's okay. So from the functional requirements, and then you talk about okay, just the high level like architecture, what components, and also the flow between them. So and then you pick the major thing, right? How to deliver a message from a sender to a receiver. I think that flow is quite clear. And then later on in the second half, then talk about like okay, how to make sure the performance is good, the scalability is good. I think this kind of layout of the presentation is good. Okay. And you the way you present your design, I think is quite clear, because it seems to me like I can understand the design and what each component is doing. So and like the communication protocols and how the data flow from one component to another component. So yeah, and you all actually one thing I want to mention here is some of these functional requirements, right? So you list it in the second slide. But I would say like when you present the architecture or the major components, make sure you cover them. Okay. So some of them is more like I ask you and then you go back to them. So
Right.
that always sometimes in the real interview I would say like you don't have time to cover them all in details, but it's still like good to say okay, yeah, in my design I take those things into account, into consideration. So when I design this system, so here and there, so that means like I can keep that requirement in mind, right? So and my design is to make sure I can meet all the functional requirements. So and then later on you can just focus on a couple of these like major things, so that they can ask the interviewer, say okay, yeah, we can go deeper into these components, or which part do you want me to elaborate, and things like that. Okay. So that's one thing. The other part is I would say like the design itself, it may work for some, like I would say if we have millions of users and things like that, I think it works. But if you say talking about half billions, then I would say I have some concern about the scalability and performance. Why? So let's talk about like look at your design, right? So if you have half billion users, even like a 10%, 20% of them are active, so you still have a lot. So the user they first of all they look at this, they're going to connect to your things, right? So and then you're going to distribute them to the multiple servers. Each server, I guess, is going to have a group manager or WebSocket manager, have its own like Radix. So one thing is not really clear here is you use a Kafka queue. Is that Kafka queue, is this for one server? Or is this for all the servers? So because you obviously need multiple, like maybe hundreds of servers, right? So and then is it like usually when I see like a design like this, actually those people they're going to use Kafka as well, but they're going to what they do is they move it ahead. So like before the all these microservices, it's just like okay, you have all these incoming requests. We are going to store them in the Kafka. So why? Because there's two things here. One is we want to make sure we want to do load balancing, so you can have a lot of subscriber taking out the requests and process them. The other thing is you want to handle these traffic peaks, okay, or hotspots. So sometimes like on that day you're going to have a huge amount of requests coming in, like 10x 10 times than usual. So in that case, how do you make sure, I mean, like your system can still handle that kind of traffic? One way to do it is you're going to store them in a Kafka queue, and you don't need to increase the number of servers, right? At that time, you just store them and then let the servers to consume those messages. In that sense, basically you have a buffer, like a buffer, and then I store them, and that's one thing. The other thing is using that basically it answer one of my question is how, like how this each server cooperate, right? Is it like you're going to, for instance, how do you start the data at all, or I mean like all each server basically they're accessing the same database, like the same Cassandra or whatever, so like distribute database. It's not very clear to me about how you do it. Is all you share the data, each server is just to supposed to take care of some, like maybe for that subset of
Services or all services?
yeah. So that part is not very clear. So because I guess maybe you need to share the data because there's a lot of data. So it's not maybe it's impossible to store all the data in one server, and then you have duplicate servers. Maybe that is not your design. So I guess you need to do that, and then you need to talk about how do you share the data and make sure the data, I mean like is balanced. Okay. If you can also have a design, say, okay, I don't want to start the data, I can just want to use a distribute database. So each server is going to access to that distribute database. I think that is okay. It just we need to talk about like what would be the pros and cons, right? What are the pros and cons if we do that? So but here now I ask you the one. I think your design is good if all the users are online users. So and then you can just maintain these web socket connections, and then you can have this microservice to process the send message, and then you identify the receivers, right? You can search them from this like a user database or whatever, and then you're going to send the message to that user using the WebSocket. So that's okay. The other thing is if the user is offline, and then the user just get online again, then your design is going to have problem. Why? So the user they're going to, okay, I want to get the messages since my last login, right? So and then I need to get it from somewhere. So it's more like you get it from a database. I think you mentioned you want to get it from Kafka. So Kafka usually is not like a support queries. It's just like a stream. So you one end you goes in, the other end have a lot of consumer goes out. It's not like a database. So and even you use a database. So and then you're going to, okay, whenever offline user want to get his messages, you're going to have a query on the database. So and then meanwhile you're still changing the database, updating it, adding more message and things like that. Then like you mentioned, there are a lot of contention or conflict out there, right? So and if you have if that database is serving millions of users, half billion users, all this contention will kill your system. Okay. So how to avoid that? So basically you want to basically somehow make sure sharding is one thing. The other thing is you want to separate the requests a little bit. So if you say, okay, I have the sender send it to the database, and meanwhile I have the receiver try to get the data from database, it's better to separate these two parts. Okay. So and also you talk about the cache. Okay, the cache is actually it's very important, cache here. So why? Because if you don't do it, then all these database operations or queries is super slow. If the requirement is to say, okay, you don't need to make it like a real time or instant, I think that's fine. But your question is you want to make real time, right? In your problem statement.
Right.
So if you look at a real system, so basically they are doing something very important. like WeChat or WhatsApp. So the key is, yeah, you're going to maintain a cache, but what is in the cache? The cache itself, basically, you need to maintain a buffer or queue for each user. Okay, like for a sender, for a receiver, you can have a buffer. The buffer just buffer the like maybe 5 to 10 messages.
Right.
Okay, yeah, and you store it there, and then if you so you when you get a message, you're going to, okay, suppose that each receiver has a buffer, right? So you're going to, and you just, even the user is offline, doesn't matter. So you're going to update that receiver's buffer by appending the message to it. So then whenever user log in again, you can immediately get the things from that buffer.
Okay. Okay.
So
So that
it's
buffer would reside on the
memory.
user
Yeah.
memory.
Yeah, you can.
Okay.
Yeah, usually it's memory, but you can also maintain it in the database as well, on disk, right? So it's buffer. What I'm saying, like just now, is used to 5 to 10. If you need more, then you need to fetch it from database. Yeah. So
Okay.
but using this usually is very good. Why? Because you can avoid interacting with the database, and also because if you look at the review system, the message when they send or receive the message can out of order. They can have duplicate messages. They can have some messages get lost and things like that. So you need a place to reorganize these messages. So messages, some usually they also comes with a sequence number, sequence ID. So and then use that thing to order or remove the duplicate things. And this thing can happen in this buffer. It's more like a queue. Okay. So now the buffer thing is also very important to handle these hotspots. So you remember the Twitter design. Twitter design, like as one user, they can send multiple tweets, right? So to a lot of other users, sometimes one user have millions of followers. So it's that this thing is similar to the group story. So if you send something to a group and things like that, the group is super big, and then how do you maintain this buffer thing, right? So then you're going to talk about push mechanism, the pull mechanism. You remember that part?
Yes. Yes.
Yeah.
Yes.
So actually, that mechanism is also used in a review system like here.
Okay.
So you need usually is you need both the receiver buffer, the or and the sender buffer. So and then you most users, you can just like use the push mechanism, push the things to it. But if you have a celebrity, have a huge group, then you don't always push. You just let the user to pull.
Okay.
Yeah. So that kind of combinations. That also is one question I asked you, right? So in a real scenario, what will happen? What will happen is like there are some like these hotspots, some celebrities, like big group. Can you handle it, right? So if you use this mechanism, it can handle it. Yeah.
Okay.
So that is the what a usual like real system you do. Usually it's very important to maintain that like a thing that buffer thing into the queue. So and also one more thing about offline users. I think for the online users, maintaining the WebSocket is good enough.
Okay.
Yeah, that is good enough. For the offline users, then how do you sometimes you need another components like the push, the like the notification service. That thing is try to just maintain like try to notify the users, and also sometimes you need to maintain these like connection information there. So when a user log in again, so you can just use that push that notification service to handle it. But that's a minor part. It's not that important. So the main thing, if you have these kind of major component designs, then it can handle it. So now one more thing here is about the database. Okay. I think you have the Redix. You store the this WebSocket information there, and then you have maybe like a Kafka. So, but the database is, I asked you about the data scheme, right? So is it like you save the receiver, the sender, and the message, and I think you mentioned HBase or Cassandra. Yeah, just sometimes you can use it as an in-memory database, but that's good. So when we talk about that, then I would say, okay, so what are the I mean like the other alternatives, or like do you need to build index in the database because you want to see the history and things like that. Or if you don't support a search, I don't think you need that. But still, I mean, if we talk about database, it's very important to how to shard it, and what kind of data schema are you going to use, and why the database will not become a bottleneck of the system. Yeah,
Right,
that
right.
part.
Okay.
So
And you also asked about like how long do you maintain the connections, right? So what would
yeah,
be the right?
so the socket itself is more like a ongoing connection. So it's
Right.
like if the user is online, you're going to keep that thing. So the there are so as long as user is online, is connected, so then you're going to keep them, right? So when the user say, okay, move to another, maybe like a network, or like a reconnect, then maybe you're going to build another socket connection. So yeah, and you can also talk about like what other schemes approach you can do. Maybe you just want to use the one way, like the server, the SSE, like or you want to use some other like communication. So yeah, I think that's fine. But for the online one, usually I think the WebSocket one is the best solution. Yeah,
Okay. Okay.
yeah. So
Okay.
and then you want to keep them because it's usually is like you open a TCP like a connection, but later on you could use UDP to send the data. So is both like I say like high performance and also
Right.
reliable. Yes. Yeah.
Okay.
So
And
uh-huh.
there was another question. So if there are multiple users logging into the same system, right? So they should be consistently seeing their information.
Yes.
So usually during the design, like, is it both users connected to the same socket and then we can get the same activity, or?
No, the socket is per connection. It's not per user. It's called per connection, right? So if the user say, okay, I use my laptop to connect it, then I have a socket connection. And if I use my cell phone to connect, I have another connection. So the connection is more like just for communication. You still need a data structure, like the buffer or the queue. You
Okay.
get the data from there, right? And there you're going to have the like the sequence number, a timestamp, and
Okay.
for the message, and use that you're going to the server you're going to return the message. Like I need to return maybe these 3 messages, and things like that. So you're not the data is still maintained in the like in the queue, in the memory, on the database.
Okay. Okay. Makes
Yeah.
sense. All right.
All
Yeah.
right. So any more questions? I would say like I mentioned, you described the functional requirement is pretty well. I think the online part is pretty good, and also I think it can scale. The scalability is more like millions of users, but for Facebook, need a little bit more.
Okay.
Yeah. Okay. So just
And
like
any improvements you would suggest in terms of like presenting or like describing information or like confidence level or something apart from the design?
yeah, I think that like I mentioned in the beginning, right? So I think your presentation or the organization of the design, I think that's good. Yeah.
And how about the introduction?
Yeah, that's good.
Okay. All right.
Yeah.
Sounds good.
Okay.
Yeah.
Then no more question. Then have a good evening. Then.
You
Yeah.
too. Thank you. Nice talking to
Okay.
you.
Bye. Yeah. Bye.
Bye. Bye.